Bismillahirrahmanirrahim. Today the topic of our discussion is the chirality. The word chiral has its origin from the Greek chir, which means hand. If a molecule is not superimposable on its mirror image, that is, it has handedness, it is said to be chiral. The hands are most common articles which are not superimposable. As you see that left hand is the mirror image of your right hand and both are non-superimposable. A glove made for your right hand cannot be wear on your left hand. Here is an example that proves that there are the molecules which are mirror image to each other, but they are not identical. So see this animation. You see the molecule and its mirror image. In this animation drawn, if the mirror image of it is rotated, you see that the different um, atoms attached to the central atom, they do not occupy the same place. It means that they are not identical. Hence, just like the hand, they are mirror image of each other but are different from each other. This property is called chirality. So, hope now you have an understanding about the word chirality. Chirality is actually produced due to a special character of the molecule and is called the chirality center. The chirality center is actually the atom which is surrounded by four different groups, making a non-superimposable mirror image. It is also called asymmetric, stereogenic, or chiral centers. The presence of a single chirality center in a molecule results in a chiral molecule fundamentally because the top, bottom, left, right, front, back faces of all they are all different from each other. A chiral center is an atom that has four different atoms or groups bonded to it in such a manner that it has a non-superimposable mirror image. For example, in this case shown here in 2-chlorobutane, see that the carbon at the middle contains four different groups at every side. You see that the carbon has a methyl group at one side, chlorine at the other end, a hydrogen at the third end, and an ethyl group at the fourth end. So this carbon, which is marked as in red color, is a chiral carbon. For a clear view, you can see this molecule in larger image. You see that all attached atoms are different from each other at this point. Let it be marked in color. So this red color carbon atom is a chiral center of this molecule, and you can clearly view that at one end it has a methyl group, a chlorine at the second end, a hydrogen at the third end, and a methyl at the fourth end. Now come to our topic again, the main section of our topic. In the similar way, let's mirror image. Again, a methyl group at one end, an ethyl group at the lower end, a hydrogen and a chlorine. This is a mirror image of this molecule. I think a little rotation will make the situation more clear, and you can view the molecules in larger window. You see that both are mirror image of each other. Molecules can possess more than one chirality center too. For example, in this case 2-bromo 3-chlorobutane. You see that here the two carbons have four different groups attached to them. For example, this carbon atom has a hydrogen, a methyl, a bromine, and this larger group, and the second or this carbon atom has a chlorine, methyl, hydrogen, and this structure attached to these. So both these carbon are chiral, which are the carbon number 2 and 3 in this compound. You can see the three-dimensional image, and by rotation you can see all angles which are present and attached to this molecule. Similarly, its mirror image or its actually this picture reflects this 3D molecule, and this picture this. So then it needs to be corrected. And now I have corrected both the pictures. You see that in this picture bromine and chlorine are at the same site, and at this picture they are at different end. You see that the upper part of this molecule, which contains the brown colored bromine, is a mirror image of, but the lower case is not the mirror image. As you can see that the green colored chlorine and the hydrogen are at different sides to each other. We can zoom the molecule up to a level and for a clear picture you can rotate the molecule up to a certain level. You can see the chirality center of the both molecules, and even you can view a larger image of both the molecule and the mirror image of chiral centers of both the molecules, which are marked as in red color. You see that this upper portion is clearly the mirror image, but the lower case is not the mirror image, as the green colored chlorine atom does not having the structure like its mirror. Such molecules which possess more than one chiral centers and are not the mirror image of each other are called diastereomers, and the molecules having a chiral center and a mirror image is said to be enantiomer. We will focus this topic later in the series. There is also a condition which determines the chirality of the molecule. Generally, a chiral molecule does not have the plane of symmetry. A plane of symmetry is an imaginary plane that bisects a molecule in such a way that the two halves of the molecules are mirror reflection of each other. As you can see that in this picture, the upper portion of the molecule is a mirror image of the lower portion, and an imaginary cutting at the middle shows that they are both mirror image of each other. You can compare very easily that they are mirror image of each other. And remember that a chiral molecule generally should not have the plane of symmetry. If it has a plane of symmetry, its chirality, chances of being a chiral decreases. And a compound with at least two chirality centers, that is achiral due to the presence of plane of symmetry, is not its isomer, and it's called a meso compound. For example, in this picture you see that the upper portion of the molecule is a mirror image and the lower portion is also the mirror image of its counterpart. This is the imaginary line, or called the hypothetical plane of symmetry. In both cases, and actually they are the same compounds and are called meso compounds. You can see that the meso compounds are not isomers, and they are actually the same compound. For example, in this case, both bromine are at the same side, although they are mirror image of each other, and hence they are identical and 3D represented structures. It is also clear that they are the same compounds. And the PDB molecule also reveals that actually they are same compounds, and they are superimposable to each other. Such compounds are called meso compounds. You can see that they are superimposable to each other. Moreover, the practical data also shows when polarized light is treated with them, they do not have different rotation. and rotate the plane of polarized light in the same way, which also confirms that they are same compounds. Hence, when you see the previous example of 2-bromo-3-chlorobutane, you see that they are non-superimposable, and if the lower part, in this case, is considered in your mind that it is the mirror image of it will result its mesoform and denote its isomer. So, although this is not the mirror image, so this is a different compound and its isomer. They are both the isomeric forms. Now, consider that any other atom other than carbon can have the chirality centers. Yes, there are examples in which other atoms other than carbon can have the chirality centers. For example, nitrogen, silicon, phosphorus, and even the sulfur. They can be can have a chiral. They can form chiral carbons, and they have chirality in their character. Note that in nitrogen the lone pair is included as one of the fourth different group. Many of the compounds of sulfur and phosphorus have been prepared having chirality and optical activity, and they are medicinally important compounds. Hope you have understand the chirality. So we will meet in our next lecture soon. Thank you.